All right. Hi, everyone. Welcome to our webinar with Anatoly Yakovenko. I'm really happy to have Anatoly here today. I just want to actually switch the view for a second. Okay, so I'm Solomon Lederer, and I actually have a slight bias towards Solana because people call me Sol, which is the Solana token symbol. But we are a blockchain education training company. We're based in New York. So if you came to us through the Solana channels, welcome. If you're a long-time Blockmatics student, fan, client, then welcome back. We're actually starting to ramp up again. We've done a lot of webinars in the past, and we're going to do a whole bunch coming up. We had an earlier one this week that you could still catch on YouTube with synthetics. And a lot of the DeFi stuff we'll be covering. We'll be doing a couple on Tezos, but we're a non-denominational blockchain company. We love all the blockchains. All the tech is great. Yeah. So really in this talk, Anatoly, I just want to go through like our audience is well, generally our audience is maybe a mix of some developers, some just general audience. I imagine the people here, it's maybe 50-50. I don't want to get too technical, but I also want to sort of dive into a little bit what makes Solana be able to do what it does. I mean, it's pretty amazing. Solana can do something like 50,000 transactions per second. I guess in practice, it's probably around 1,000 now. The block times are super fast, like 400 or 500 milliseconds. So yeah, this is some incredible stuff. And, I kind of went through cursory read through the white paper, and I guess for myself, I'm trying to understand, and hopefully our listeners could use this conversation to then read the white paper themselves, look at the tech, and then get more involved.
Sure.
Yeah. So I guess we'll start with the core sort of innovation, or at least one of the core innovations. You list sort of like 8 big ones on the website, everything from proof of history, tower, Byzantine fault tolerance, Gulf Stream, I think as well.
Yep.
Anyway, yeah, there's a whole list. So let's cover proof of history.
Cool.
How would you explain that? And
yeah,
and then we'll go.
It's the only one without a beach name. With a
yeah, right. Everything else is some water, really sea level.
Yeah. So again, my background is I spent most of my career at Qualcomm, which is a mobile chip manufacturer. And if you have a cell phone, there is definitely a piece of tech that was built by Qualcomm, and I might have even worked on it. I kind of worked all over the place doing performance optimizations. So the key thing that's interesting about radio and radio protocols, if you go back in time and to your physics classes, you should remember that radio interferes. But radio transmissions interfere when they're over the same frequency. So if 2 towers transmit at the same time or the same frequency, get noise, and the receivers don't know what the information was that actually was transmitted. So this is a similar problem in blockchain. If 2 block producers produce a block at the same time, there's a fork, and nobody knows what the state of the network is. It's in a noisy state. So you have to kind of reconcile what happened. So how this is solved in radio is the first idea that people had is, why don't we give each one of these towers a clock that's synchronized, and they alternate by time. So if you can keep the clock synchronization really tight, like there's no errors, right? Because you imagine once they drift, they'll start interfering again. If you can keep that really tight, then they just take turns by 1 second, 20 milliseconds, 5 milliseconds, whatever that like tolerance is. And you can increase the number of transmitters, per second. And that kind of eliminates the problems when you have one of them fail, right? Like if one of them has failed and that next one goes in 2 seconds, that's worse than if the next one goes in 20 seconds or 5 milliseconds, right? Does that make sense? Like as the clocks get better, as the alternations and the number of producers per second improves, you kind of start eliminating what appears like dead zones or dead drops for users. Because past a certain point, us for voice humans, we just don't even notice it.
I guess like I guess I always think of consensus algorithms is there's some mechanism to effectively it's not really what's happening, but effectively like choose a leader. So think of blockchain, we have transactions going in every which way coming in from here, and we need some way to reconcile whether there's conflicting transactions. I guess the classic thing is a double spend problem. So you have one entity, like one leader that is ultimately picking which transactions to, I don't know, put together, in a blockchain that's put together in a block and then published.
So leader election is the same thing as consensus, right? Like actually picking the leader is the same thing as like equivalent to to implementing consensus.
So are you, so I've always understood, or I always think of it that the leader election process takes a lot of time because, like in a traditional system, something like in a proof of work system, Bitcoin and Ethereum, we have there are those long block times. Bitcoin, everyone knows 10 minutes. Ethereum, it's like 13 seconds. Because if the leaders switch too often, or if there's too often that you can have multiple blocks being published simultaneously, then you get into trouble where you start having to drop blocks, which, I mean, in any blockchain, you do have momentary divergence or forks in the network, and then ultimately some leader would emerge. So how do you sort of, so maybe you answered this already. So I guess I'm trying to understand, like, how do you able to select a leader faster?
Right. So this is our cheat code, right? So proof of history is, it's this cryptographic process called the verifiable delay function that when you look at this data structure, you know that it took a certain amount of time to generate it. So it may be, the real time may be different, but you know that some amount of time like was spent generating, and you know that like if it was running in the same hardware, a structure twice as big would take twice as long, right? So you have some relative like understanding that there is real time passing between events. So that it is our logical clock, that domain of like how big this data structure is. And you can almost think of it as a water clock or a sand dial. Like the more sand falls, you can see time moving forward, or the more water level. So this level of data grows. We don't really care what the data is, but the actual kind of like cryptographic sand clock, right? Like as that data grows, we see that time is passing. So how we deal with leader election is that we map out into the future, like for 2 days worth of every 400 millisecond slot of who's supposed to be the leader in that slot.
So is the leader actually switching every 400 milliseconds, or does it stay consistent for those 2 days or so? Because I know there's a concept of an
you can configure it, right? So that's like a configuration option. Right now, the way it's set is they switch every 4 slots, so they're elected for 4 slot periods. And
so
the block
a slot is sort of like that block. So a slot is equivalent to 500 milliseconds.
400 is the target.
Okay, I see.
So you can think of it every 1.6 seconds, the leader switch, and we can like as the network performance improves, we can say like they switch every 2 slots, and the slots are now 200 milliseconds. Like as we just get better at software, like machine this thing down and improve it, we can tighten those bounds until there's a switch every 100 milliseconds, right?
Gotcha. So, and I guess because of this timekeeping mechanism, when you do have a switch, everyone is able to incorporate or interleave the work that it was done by the previous generator.
this
Or
is kind of, if you're familiar with Tendermint, this is the main
Mhm.
difference, is that a single Tendermint leader proposes a block, and then everybody goes through these classical PBFT rounds of consensus
Yeah.
saying, Saul produced a block. Everybody agreed that he produced a block. Let's move on to Anatoly, right? Like,
Right.
and then I
Okay.
propose a block that hopefully attaches to yours, or could be a view change. So that kind of like sequential leader election is really slow, because it requires the network to synchronize in every block. So in Solana, it's very much like TDMA. Once we have the schedule allocated, once you've allocated your slots, you go, and I don't actually wait for you to stop. Like I as soon as I get to my slot, I make my decision. Okay, did I observe data from you? If so, then I attach to your fork. If I fail to observe data from you, I just produce a fork. And those forks are like, they're much faster to resolve, because that decision is like a single leader, a single node that makes it. It's the next one.
Okay. So would it then be, and I don't quite know, or I'm not completely familiar with exactly how Tendermint works, but I do know, I believe the Cosmos blockchain, which is using Tendermint consensus. I know. What are the block times there? Is it also like a
5
couple
to
of
10 seconds?
5 to 10 seconds. So is that kind of, by using proof of history, is that what allows you then to ultimately get down from that 5 to 10 seconds to the half second? Yeah.
So our bottlenecks are not, so the limit of where we can go is how long it takes for packets to travel halfway around the world. So if a block producer transmits, in like China, those packets arrive in the United States, and then that leader takes over. That's best case scenario is, 100 milliseconds.
Yeah, and I guess I've always thought it took longer. I think maybe this was a lot of kind of the misinformation when I was first learning about distributed systems or Bitcoin, and just people make the argument that it takes like 2 seconds for everything to go around the world. But I guess the reality, doesn't take that long. So I always thought that was like a lower limit, but you're obviously, broke that limit.
When you do video with somebody in China, is there 10-minute intervals between what you talk?
Yeah, you're right. I think we are. And I do hear you talk a lot, or not a lot, but I've heard you say before that Solana is really taking advantage or making use of the fact that our hardware is getting so much better and faster. And we don't need to make assumptions that everything is going to break, or everything takes 3 minutes to do. And you are sort of leaning more heavily on better hardware and faster. So I guess my question is, how much of the Solana technology and protocol is really leaning on that? So like, how would Solana fare? Look, we're using proof of history and the other consensus, the proof of stake mechanism that you're using. How would it work if you did have lower hardware requirements, or what?
So as scalability, as it's understood, like outside of crypto, is really what it means is to be elastic. Is that can you build a software such that if I put more money in, buy more cores, more hard drives, that it just scales to a larger number of audience, right? They can do more of the same. So this is kind of how we've designed everything. We've had scalability in mind from the start. And if we had, hardware 20 years ago, it would run, but just, it'd probably need 5 seconds block times, right? Like, because the amount of processing power necessary to process all the signature verifications wasn't there. So the kind of the bottlenecks in consensus are this problem with Bitcoin or Ethereum is that it tries to avoid forks, right? So it sets the difficulty such that it's unlikely that there's 2 blocks that produce at the same time. If they set the difficulty faster, so there was a block every second, because of communications delays, you would just see a lot of collisions in Ethereum. And that would be bad, right? So Bitcoin is like really conservative. Ethereum is maybe the fastest proof of work system that's reasonable on a global scale. Tendermint, right? Same problems, like because it is a global network and you need to synchronize all of these nodes before you move from block 1 to block 2, you have to process all these signatures. And that synchronization is what kind of stretches its block times, because they do this in every block. Solana, we have this schedule to produce blocks, but votes themselves are not processed between blocks. Votes are transactions that get funneled into the same Gulf Stream like path, and then they appear sometime later, right? So you may produce a block and I may not see any votes on it, and I may attach my block to yours, and then we'll start seeing votes later aggregated in some other leader's block for everything that was done by the network. So we don't like stop, right? Like we just don't stop producing blocks. We just kind of
so even though you do need, I believe, what it's two-thirds of the other nodes or validators to sort of vote yes on a particular block, those just get funneled in later. So you're not waiting for all those yes votes to come in.
And they can amortize their votes by voting on the entire fork and effectively voting for all the parents.
Right. So you're voting like one. So how often does that actually happen? So like every time you vote, are you generally voting on like the past 6 blocks or like?
It's usually like a few, right? So we see that we have this thing called optimistic confirmation, where we can give you deterministic finality that this block is going to get confirmed. And so that's, for that to happen, you need 2/3 plus X to vote on a block. So that X would have to be faulty for that block to switch, to get it rolled back. We see that on mainnet right now, somewhere between like for the majority of the blocks under 2.5 seconds. So the times between optimistic finality, right? So on average, your transaction should see about 50% of that like confirmation time. When you click a button, it's likely to land somewhere in the middle of that, and then you see it confirmed, right?
So you just said 2.5 seconds. Are you saying till you have like probabilistic finality is
deterministic?
Deterministic.
So yeah, so we don't have any randomness in the network. Everything's deterministic. So
there's a lot for my head to get around here. Yeah.
As soon as 2/3 plus X vote on a fork.
Oh, that's it. It's final. Yeah.
X have to be faulty. X have to cheat and try to switch forks without the appropriate switching proof for that fork to be not committed. And the switching proofs require that you observe at least 1/3 of the network voting on some other fork besides yours. So does that make sense, right? We have like 4 people. We have 4 people in the group. They all vote on a fork. It's impossible to construct a proof that 2 of them voted somewhere else, because we all voted on the same fork.
Gotcha.
Right? So you, as soon as you observe that, you're like, okay, there's no way that this block will ever get rolled back. Will ever get rolled back, and that's the confirmation.
Gotcha.
Okay. And then eventually it hits this full 1/3 faulty, like standard PVFT. I don't know if you want me to explain Tower, but basically,
yeah, I actually did want to get a little bit into that and understanding what you're actually doing with that's different from practical Byzantine fault tolerance. So you have a change. I do want to just tell the audience, everyone watching, we are going to do questions at the end. So in about 5-10 minutes or so, we'll start taking questions. We'll do a few minutes of questions then, but obviously in the interim, you can post them either on the Q&A tab, or I believe people are just throwing them in the chat as well. I'll try to go through them. But yeah, I'm sure people there's a lot to really understand. You know, I just wanted to mention, like, the Solana white paper is 32 pages long compared to the Bitcoin one is 8 pages long, or 9 pages. So It
Yeah,
is
and it's
definitely
a
a lot more
complex system.
complex. Yeah, which everything is a double-edged
Right.
sword. You get a lot of improvements by the complexity,
Yep.
but then of course complexity is harder to understand and validate and verify. But
Yep.
yeah,
So
anyway, continue with the tower.
yeah, so we really wanted because half of the team came from Qualcomm, we really wanted to avoid this Tendermint style, let's agree on block 1 before we move to block 2. Because that's just not how radio towers work, right? Like radio towers don't wait for tower A to finish logically, right? They wait for towers A slot to finish and then tower B goes. And if there's
Yeah, I
interference, it's
realize that
because
this point is like literally the number one thing that I didn't really get when I was trying to understand the Solana technology, the system, because yeah, realizing, because I couldn't wrap my head around like how everything gets sort of agreed upon in the 400 milliseconds. But you're saying, right, you're not waiting for all those agreements or all those yeses.
Yep.
Yeah.
Yeah. So if you have if that's like the transport layer, right? The physical how data's passed, there's a logical layer on top of this that actually tells nodes as they're moving forward, like, is this block how it's connected to the previous block, which may skip slots, right? It may skip your slot, right? Because you failed to produce a block, or your fork was just pointing to some random thing that nobody cared about, right? Like you had invalid data. That actual physical transmission of data is a separate thing conceptually than the logical part of how the structure of the forking of the network is set up. So in a slot, you still have a block. So that block is proposed by a leader during their slot, and that block points to some random block in the past. So for us to come to consensus, what is the live fork? There needs to be some consensus mechanism on top of this. And we really wanted to avoid this, like, let's do a round of consensus in every block, because that's excruciatingly slow for applications that just want their data to go in and they want to see that, like, my trade is in the system, right? I can then start, like, it's effectively not a real-time system. Like Tendermint is not real-time. What we're trying to build is, from the get-go, how do we compete with NASDAQ, with CME? It needs to be a real-time system.
Right.
So
Amazing.
we have this different approach where you still have Byzantine fault tolerant properties, and you still can only support up to a third of the network being faulty. But it doesn't have this synchronization on every block. So how it works is that every time I submit a vote to a block, I am committing a bit of safety to that block. And by safety, I mean that if I vote on block A, I will not vote on anything that doesn't include block A as a parent for at least 2 slots. And we can measure those slots in real time, right? Even though it's a logical measurement, because the underlying thing is a verifiable delay function, it actually takes real time for somebody to produce that fork of block A plus 2. And therefore, I can't double vote and create both of these at the same time and denial of service to network, right? There's actually like some amount of real time that has to pass between those events.
Gotcha.
So, and every time I vote on a child of block A, all my parent votes double in lockout. So that's an exponentially growing function, right? So you can imagine after like 32 votes, I have 2 to the 32 worth of slots that I'm not supposed to roll back. Like I have to wait before rolling back. At 400 milliseconds, that's 53 years. So that's kind of overkill because our epochs is 2 days. Anything above an epoch doesn't kind of logically make sense, but we like power too, so we left it as 2 to the 32. And
so and I see. So the 2 to the 32 is the epic time, which we
that's the full tower. That's the full tower lockout time. And once you have a commitment to a block reach 2 to the 32, we just assume it's fully finalized, and we kind of give you a voting point, and then those voting points are claimed as rewards. So that's when you kind of like spit out your staking rewards through voting.
Right.
So
yeah, which is a whole nother part which we didn't get
Right.
into or have the time to get into is sort of the proof of stake
Right.
integration too. But I don't know, can you sum up it like maybe shortly why, what is the main motive to incorporate the, the proof of stake aspect, or why is it needed?
You still need some Sybil resistant mechanism
Mm,
to give a weight to a vote. So
okay,
with
right.
proof of work, that's your hash power, right? So I can
Mhm,
prove hash power by solving difficulty, a problem of exceeding difficulty, right?
gotcha.
With proof of stake, if you don't want to spend electricity, right, you need something. So proof of stake is that approach. Um, so
Mhm,
that's based on staking, and there's a 2-day epoch where we regenerate the leader schedule, and that's the warm up and
yeah,
cool time for staking. So
yeah.
that's your once you're in the leader schedule, you're kind of like an active node. So we need 2/3
Mm,
of those to continue voting. If 2/3 of the nodes in the leader schedule continue making blocks and voting, then the network continues running. Um, and to kind of go back a bit to Tower, the safety proof is pretty obvious, right? If I'm an outside observer and I see that 2/3 of the network has 2 to the 32 lockout on a block, I know that 2/3 of the network has to wait 53 years for that block to roll back,
okay,
right? So therefore, I can like guarantee that it's fully committed,
right.
right? And the hand wavy proof of liveness, right? If I'm running a block producer and I get stuck on some fork, I
Mhm,
can stop voting until that fork times out, and I'm fully all my votes expire, right? And then I can switch forks to whatever the network is. And that's a very hand wavy proof. So
yeah.
if you're an academia that you're listening to this,
y-
I'm sure you see
So
why it's hand wavy, but that's kind of the general principle there.
I gotcha. All right, amazing. Yeah, I definitely feel that this gives us, I have obviously a bunch of questions, but I think this still gives us a nice, general overview. So people really, it's a good intro and people can take this, read the white paper, get into some more the technicals of Solana. What would actually be, before we take questions, what would be, I don't know if you want to talk a minute about if somebody wants to get involved with Solana. I know you have like a big grants program.
Yeah. So
I mean, you guys are pretty active in like hackathons and just
yeah,
getting
we had a lot of
things done.
success with our last hackathon. Even the first one, we had 1,000 registrations. The second one had 3,000 registrations. And what was amazing is like about 11 teams got funding after the hackathon. And not even some of the teams that didn't even win it.
Hmm.
They built a product. It was really hard for us to pick like the winners. And
Oh,
some of the teams that weren't selected as any of the winners got funding, like seed level funding. So that was really wild to see. So we have another hackathon running now. If you go
hmm,
to solana.com, I believe it's under /Solana season. Maybe I can
hmm.
post that.
Sure.
And there's a ton of documentation on how to get started as a dev.
Hmm.
So I would highly recommend that you jump in and just go try something.
Hmm.
Um, a lot of the folks that got seed level funding in the second hackathon, they had tried to build something in the first one and it didn't work, but they kind of continued following the space and like trying stuff out. And
Yeah.
they kind of took advantage of the second hackathon and the opportunity to kind of get into the space. So this is the easiest way for you to somebody that doesn't want to quit their job yet
Hmm.
to see if you have the chops and like the necessary willpower to kind of go at it.
Yeah, but it's amazing to see kind of what you're offering out there with the hackathons and just the incredible growth with Solana. I mean, now I see your, believe like last I checked, 16th position on CoinMarketCap. So I mean, you're definitely one of the top blockchains, which is incredible. Let's jump to some questions. I don't know if you want to just pull up oh, actually I have the chat. If you pull up the Q&A window, might be easier
Yeah.
if you want to look at them, because then you can pick which one you think be most useful or new to talk about.
Yeah, that question, the first one, what stops the leader from ignoring block created by the previous leader? So those lockouts, as your
Mhm.
answer, like I think you hit on the intuition there. because as soon as I vote on Sol's block, if the next leader proposes a block that doesn't include him, I am locked out and I can't vote on anything that doesn't include that fork. So because everything is happening in real time, it makes it very hard for you to start censoring individual leaders, because you don't know if the supermajority voted on them before you start producing your block. And if you wait, you effectively delay your block, and the likelihood that you'll get dropped increases the more you delay. So we get kind of like this nice real-time guarantees that, it helped with censorship resistance. There's no foolproof way to do this, but it definitely seems like it helps. When are you going to add more people to the team? They're overwhelmed.
Is that someone from your team asking that question?
JH? We are, it's really tough to hire because we're all like, I don't know if you guys have been in crypto for the last 2 years, have kind of suffered through the bear market and have been kind of drinking the Kool-Aid. Folks coming into the space are coming into it fresh. To them, everything is like bizarre, and they don't quite understand it. So we are engineering, like we're doing pretty good job staffing, because engineers, like, we can explain to them, this is the hard engineering problem, go at it. But for designers, for like folks that understand like UX and like human interactions and how to explain these really complicated concepts to non-crypto people, like that like semantic compression, that's really tough to find like amazing folks.
Yeah, I hear that. I guess JH has a lot of questions here. Why the decision to remove foundation rewards for validation? I'm not familiar what that is, but
yeah,
if you want to take that.
So we have this like delegation strategy that's been part of the open development program in the foundation. How does the foundation incentivize censorship resistance? So that's been like an open discussion in the ecosystem. And I don't know if you saw that, like Lido and Chorus One are building liquid staking. So our goal with incentivizing delegation on the network is really to focus it towards censorship resistance. And I personally believe that the only way to achieve it at like sustainable global scale is with liquid staking, which is a really cool concept, right? I stake with the network and I get a token back, and that token can be used in DeFi, but those tokens are not fungible with other stake pools. There's some properties of those stake pools that are unique to each one. And the ones that I believe are going to succeed in the market are actually the ones that maximize censorship resistance for the network. Because all the DeFi projects, those are marketplaces. By definition, marketplaces depend on censorship resistance. To have a fair and open market, you need censorship resistance. So we kind of have these like nice virtuous cycle between like Serum, Radium, like these marketplaces promoting and supporting like staking pool tokens that actually maximize censorship resistance across the entire network. I kind of think that that's the only way this stuff is going to meaningfully have impact. If you look at like Ethereum 1, 5 mining pools at up to 51%, ETH2 staking distribution 4 at up to 33%, which is that threshold on proof of stake. On Solana right now, there's about 15 nodes that you have to, that the minimum set of nodes that add up to 33% is 15. We want that number to be 1,000. What did you just say
it was for F2? It's how many? 5?
Four entities control add up to over 33%.
33. Oh, interesting.
So if you look at like that distribution, it's like Kraken, Binance, Lido. And that's not something that they're optimizing for. So ETH2 is not like I said, like we had we've been focusing on building something that's competitive with NYSE, with CME. My seed levels, like seed slides were like Solana, blockchain, and NASDAQ speed. Like we've been thinking about like, how do we build this censorship resistant global price discovery engine? There's two pieces to that. One is ridiculous performance. We need state transitions that propagate around the world to propagate through Solana at the speed of news. Something happens in Hong Kong, as that information propagates to a trader in New York, they need to see that price reflected in both in NYSE and a market in Solana. So that's just like nuts and bolts of what we're doing optimization. But then the larger problem is, how do we ensure that this thing is censorship resistant? How do I know that when I submit a trade, there isn't some small set of entities that can basically coordinate and decide that my fund goes first or my fund gets deprioritized? And that we need, the only way to do that is to maximize the minimum set of participants that add up to that 33%.
Gotcha.
And
so I
think,
yeah, which is amazing because it really, sorry, finish your thought.
Yeah, the only way to do that, I think, is to have these like virtual incentives for stake pools that are like folks that are participating in DeFi and staking in the network, that those things actively maximize that censorship resistant set. So it needs to be this like education plus DeFi component that's like a fundamental block of DeFi. Needs to be a staking pool token that is maximizing censorship resistance.
Gotcha. Actually, which brings me, I see somebody, Y Choi asks, I mean, when I read this question, I thought it was more of a DeFi related question about front running being a problem for many blockchains. What protections does Solana have to prevent this? So yeah, initially I didn't think this was actually a blockchain question, but maybe what you're just saying, actually Solana does help against this.
Yeah, the real answer to this is you need like fair and open markets for front running. Like, if that makes sense. Like, you need everybody to understand that it's possible, and that if everybody's competing at it, that means that I will pay you for your order so I can front run it, right? I can extract value from it. And the way you can kind of think of it, let's say in 10 seconds, how many block producers can we stuff in that 10-second interval? And if you care about your trade landing in 10 seconds, you can pick the one that gives you the best offer. Like, hey, take my order, right? Like, then I will make sure to include it in the block, and it's not going to get front run, or I will extract X amount of value for it and give you a rebate, right? That may actually be like the system. And some cool things that we can do in the future is potentially run multiple block producers, not sharding, producing blocks concurrently at the same time that are ordered by time in real time. So, which is like the equivalent of going to CDMA from TDMA. So so that's like that would mean that, you know, if you have 8 block producers per slot, then in 10 seconds you have hundreds of potential targets for your order. And if they're all competing to give you the best possible, like, you know, price, right, for your order, you might actually make money as a trader, right? Like, you might get rebates like you do on FTX, like you do on IZ. So that's kind of like the long.
Wow. Okay.
That's the long-term goal, right? Like maybe 22 is when we'll get to it. We have like a ton of other fires to work on.
I'm sure. Well, which brings me, actually, I want to just maybe close on this question is, you know, really, like, the more you talk, and it just really seems incredible, almost like too good to be true. But what would you say, you know, is something that is, I know I'm not, you know, maybe some downside of the Solana model.
So this new computational like operating system, right? This like replicated state machine that everything is cryptographically controlled. It was like theorized 20 years ago, right? This was PBFT. Like, people were like, in theory, this is possible, right? We have internet that's censorship resistant, and we have cryptography to verify everything. Then in theory, we can build these systems. Right now, we barely have the hardware to do it. So the hardware is expensive. It's not like ludicrously expensive. We are embedded systems engineers. We like know how to squeeze everything out of like PCs and gaming systems. But the difference between our ethos and our philosophy is that if we can build use cases that scale to 1 billion people today on hardware that costs $5,000 a pop, then the hardware is basically free compared to the value creation of somebody scaling this out.
Is that what it would cost? Like, if I want to just set up a Solana validator or block generator? yeah, it would be
just think gaming PC. Like, can I, like, if I'm building like a new gaming system, like $3,000 to $5,000, depending how you configure it, and that would be sufficient to run, you know, NYSE, right? To disrupt the banks, disrupt all the exchanges, just a bunch of randoms
put it
with
that
gaming
way,
PCs.
doesn't sound too bad on that perspective. Yes, Anatoly, thanks so much for your time. For those who asked,